Good morning, Algebra 2 Trig Honor students. So this one is for Trigonometry 4.4 and the other type of trig function. We're going to break it apart into two sections. So the first section would be the tangent cotangent graph, and the other sections, the other part of it, then that would be for the secant and the cosecant graph. So we'll get to all those forms once again. So for those you might be wondering about the tangent cotangent, this one it doesn't show any like a basic form or the standard form. Well, that's something I'm about to show you right here. So that's a basic form for tangent and cotangent is always written as this. So it's y equals a tangent of bx, and the other one is y equals a cotangent of bx. Okay, so there's another video I'm going to refer to, so you guys can watch that one too. It's the one that I put in all those forms. And what about for the standard form? So the standard form, that would be just y equals tangent of x minus h plus k. Okay, so for those you might be wondering, well, there's no a. If a is not given, that means 1. Okay, so standard. And then the other one is y equals cotangent of x minus h plus k. And then again, alternative form or the alternate form of tangent and cotangent is written like this. So tangent of bx plus c or cotangent of bx plus c. Period for tangent and cotangent, the parent function, it's always pi. So the period, it's pi over b. And then the way to find the phase shift, similar to what we did for cosine and sine, it's negative c over b. Okay, so now to look at that, graph 1 complete cycles of each of the following. So y equals cotangent of x minus pi over 4. So started with that, identifying the value of a. Now keep that in mind. A, it's not the amplitude for cotangent and tangent. So a is just a scale factor. Okay, so notice. So a, it just considered the scalar. So it's just the scale factor. It shows that whether it's stretching or shrinking. So that's something I'm going to show you on the next slide. So a, notice, it's not, well, it's not the amplitude. Alright, so for cotangent and tangent, so a, it's not the amplitude. So graph 1 cycle, so let's identify the scalar. So it's 1. And then the value b here, if that's not shown, so this one, well, it's already factored out, so it's 1. So that means the period, so it's pi over 1. So which is pi. And then the value of c, well, the value of c here is just what? Negative pi over 4 divided by 1. Well, it's negative pi over 4. So negative, then that'd be positive, divided by 1, so it's pi over 4. Well, just identifying the value of c first, and then identifying the phase shift. Excuse me. So the value of c, it is negative pi over 4. And then the horizontal phase shift, negative pi over 4, divided by 1, which is pi over 4. Or this one, obviously, because that's already factored. So the value of h is just what? Pi over 4. And then the one cycle test. For those you might be wondering, how do I do the one cycle test for cotangent? Again, base of the parent graph of cotangent is from 0 to pi. If you guys watched the attached video, the other video that we referred to, or the lesson that we did with the parent functions of cotangent and tangent. So the one cycle test is bounded in between 0 and pi. Well, because those two positions, those are the vertical asymptotes for the one cycle. And now we want to put in the quantity, x minus pi over 4. So add pi over 4 both sides, the left and the right. So we got pi over 4, it's less than x, it's less than 5 pi over 4. Okay, so we need the x-axis and the y-axis. Okay, let's use purple this time. Okay, so pi over 4, 5 pi over 4. Okay, so half of the distance. So this one here, it's 6 pi over 4 divided by 2, 6 pi over 8, which is 3 pi over 4. Okay, so 4 pi over 4 divided by 2, pi over 2. Over here, 8 pi over 4, 2 pi divided by 2, that's pi. Again, at pi over 4, that's the first vertical asymptote with that one cycle. And then this one is the second vertical asymptote. Well, the reason why we just need one complete cycle because the rest of this is all about repetition. And then back to the cotangent parent graph, we do know that at the next position, so that it's going to reach up to 1. If the scalar, it's not, well, if the scalar is just 1, so this one, it just reach up to 1. It's just like cotangent of pi over 4 at that position, but it's being shifted to pi over 2. And then all the way down here, then that'd be 0. And then all the way down here, then that'd be negative 1. Because we do know that cotangent, it's an odd function. And then for those 3 dots, basically just connect them. So this one is kind of like a reflected cubic curve, but with the vertical asymptotes. So the graph goes like this. So again, this part right here should be a little bit more deeper for the curve. Okay, let me just reconnect this part. So again, it's just a reflected cubic curve. All right. Any questions? So if you have any questions like this, so make sure that you put it into the comments and also send me the message through the YouTube channel. Okay, so now, again, the next one, let's see what else that we have. So we got cotangent and now tangent. So similar to the cotangent one. So for the one cycle test of tangent is from negative pi over 2 to pi over 2. So first thing that you want to find out, the value of A, which is 1. And then B, which is 2. Now for those you're not quite sure what to do, this one you can always factor it first. So tangent of 2 times x plus pi over 4. So this one it's a lot more obvious if you do it this way. So then period, then that'd be 2 pi over 2. Well, it's actually pi over 2 because that's the tangent. So the one full cycle, the one full period for tangent is just by pi. So it's pi over 2. And then the horizontal phase shift. So this one is just negative pi over 4. We can find the value of c back to this one. So the value of c is just pi over 2. And then the way to define h, similar, negative pi over 2 divided by 2, which is what? Negative pi over 4. And then the one cycle test. So from negative pi over 4 less than, well, negative pi over 2, negative pi over 2 to pi over 2. So 2x plus pi over 2. So subtract pi over 2. So this one you'll get negative pi less than 2x. Subtract pi over 2, you'll get 0. Because negative pi over 2 minus pi over 2, negative pi, negative 2 pi over 2. So it's negative pi. Divided by 2, so negative pi over 2. It's less than x, it's less than 0. Okay, like that. We're going this way. So this one, the one full cycles. So it's from negative pi to 0. Okay, so negative pi to 0. So again, at those two positions, we'll get the vertical asymptote. The VA. And half of the distance, so negative pi over 2. Over here, half of the distance, negative pi over 4. Right here, half of the distance, then that would be negative 3 pi over 4. Okay, so we do know that's a tangent curve. If that's a tangent curve, so that means at negative pi over 2, that's a 0. Negative pi over 4, so that's right up here, it's 1. Again, if the scalar, it's not given, it's always 1. And then over here, then that would be negative 1. So this one is just like a cubic curve. Okay, just like that. Oh, this one just misspelled. Ultimate, the ultimate form. So again, the ultimate form, the alternate form, and standard basic form, the structure is quite similar to that sine, cosine. But the only thing that I changed that is the functions, the trig functions. Okay, let me fix this one here, ultimate. Okay, so the ultimate form of tangent and cotangent function. You guys see that? So y equals k. Again, we do have the same kind of element, a, b, h, and k. So y equals k plus a tangent of b times the quantity of x minus h. And then for cotangent, it's quite similar. So just change the function. So again, where b is greater than 0, period, pi over b, phase shift, just h, vertical translation, that's just k. Now again, as what I mentioned before, the a, the scalar. So if a is greater than 1, so that means the graph would be stretched vertically. So that means the graph, the cubic curve will be becoming what? More, well, it's going to become skinnier. Okay, so it's going to become skinny. And what about if that a is less than 1 but it's greater than 0? Well, that means it's compressed horizontally. Well, that means it's getting fat. Okay, so one is skinny and the other one is fat. Okay, so we'll take a look at that, the example in a minute. Again, the structure, very important. Things I need to find out. Scalar, the value b, horizontal phase shift, and the vertical translation. Okay, so right here. So identifying the following elements. So what we got here, so this one can be written as y equals negative tangent. Again, the 1/2, we can put it out 1/2 times the quantity of x plus, well, since we take out 1/2, so this one is considered 2 pi over 4, which is pi over 2. Because 1/2 times pi over 2, then that would be pi over 4. And then minus 1. And then for a, absolute value of negative 1, then that would be considered 1. Scalar just 1, so it's just a normal curve. And then the value b, it's 1/2. So that means the period, pi over 1/2, 2 pi. And then h, negative pi over 2. And then for k, okay, let me just put it down here in the bottom. It's a lot of stuff need to be showing here. So h, negative pi over 2, k, negative 1. And then the 1 cycle, and also another thing, reflection over the x-axis. It's the negative sign right in front of that a. And you can do the 1 cycle test. So this one, it goes all the way from 0 to, well, tangent is from negative pi over 2 to pi over 2. So the one that we want to put in here, it's 1/2 x plus pi over 4. Or we can put it into factor form right here in the middle, same thing. So subtract pi over 4, so negative pi over 2 minus pi over 4. So this one, it's considered negative 3 pi over 4. Okay, so negative pi over 2, it's negative 2 pi over 4 minus pi over 4, negative 3 pi over 4. So less than 1/2 x, it's less than 2 pi over 4 minus pi over 4, pi over 4. And then multiply everything by 2. So what happens if you multiply everything by 2 here? Well, because you want to get rid of the 1/2. So we got negative 3 pi over 2 less than x less than pi over 2. Okay, so without any kind of reflection, without any kind of vertical translation. So let's sketch the parent graph. So we need the x-axis and the y-axis. So this one is from negative 3 pi over 2 right here. Here's 0. Here's pi over 2. Again, at those two positions, those are the vertical asymptotes. And the midpoint in between those two asymptotes. Okay, so this one combined them. So negative 3 pi over 2 plus pi over 2. Then that would be negative 2 pi over 2, which is negative pi divided by 2. So negative pi over 2. And then this one halfway through, so 0. So minus pi over 2, negative pi. Okay, so with a normal tangent curve, so this one, it's just like what? Right here at 1. Down here on the bottom, it's right at negative 1. Well, it's dotted. This one is dotted. Don't make it solid, because that's just the parent function. And then with the vertical translation, so it's 1 unit down. 1 unit down. Okay, so a negative pi over 2, 1 unit down is right here. Then 1 unit down. So this one all the way down to negative 2. Try to extend this one a little bit further. Again, this one is just another parent graph without the reflection. So it's still considered dotted. And then finally, with the reflection. The reflection is over the x-axis. So this one down here is negative 2. So now it goes all the way back to the top. So it's positive 2. And then over here, 0. 0 just remains the same. Well, let's see. With the reflections. Okay, so over the x-axis. So this point here, reflected over. Yeah, this one just remains the same. So down the bottom, so this one is supposed to be, well, here's negative 1. So negative 2 should be the one all the way down here. So it goes all the way up to positive 2. Again, I need to extend this x-axis, the y-axis. Oh, you know what? This point of one that I reflected. So this one, give me one sec. One more time, reflected over the x-axis. So negative 1 reflected over, so then that's 1. And then the next one, this one will be what? Negative 2, then that would be positive 2. And then over here, 0, it just remains the same. Okay, so simply just connect them, final graph. Again, it's just the reflected cubic curve. Alright, and now what about for the cotangent? Okay, well, this one, again, similar to the one that we did. So for this one, A, which is considered absolute value of negative 1/2. So it's 1/2. And then B. So again, this one is not that obvious, so you need to swap the terms. So let's just rewrite it. So it's y equals negative 1/2. Cotangent. So for that pi over 2, that's the value of b. So let's pull that out. So pi over 2 times x minus, well, this one is 3 pi over 2. So what's left here is just minus 3. And then don't forget, f3 half. So the value of b is pi over 2. And the value of, well, the period, pi divided by pi over 2. So it's 2. And then the phase shift, which is 3 units to the right. And then the value of k, 3 half. So 1 half, that's a scalar. So that means the graph is going to be considered horizontally compressed. And then with the negative sign, so with the reflections, it's over the x-axis. Okay, so try to do the one cycle test. Okay, let me just put in this one to the new slide so it's easier to see that. Okay, let's just snip this whole thing. Well, it is a little bit complicated once we deal with the ultimate form. There's so many things involved right here, especially once you deal with the fraction as well. So it's even more complicated. Okay, so reflection over the x-axis and the one cycle test. So this one is from 0 to pi because that's cotangent. So pi over 2x minus 3 pi over 2. So add 3 pi over 2, so we do have 3 pi over 2 less than pi over 2x less than pi plus 3 pi over 2. So this one would be 4 pi over 2. Well, 5 pi over 2. Excuse me. Because that's 2 pi over 2 plus 3 pi over 2. 5 pi over 2. And then divided by pi over 2. Or in other words, multiply by 2 over pi. So we got 3, it's less than x, it's less than 5. Because that pi over 2 got canceled. Okay, so this one, let's just customize the scale. So we need the x-axis, y-axis once again. So this one is right between 3 and 5. I can always customize the scale, so let's just go by 3 here. And then 6. So 5 should be the one right here. Okay, so 3 and 5, so VA dotted. At 3 and 5, so the vertical asymptote. Okay, so now let's see what else that we need to put in for this one. So let's start with the parent graph without the vertical translations and also without the reflection. Okay, so we do know that's a horizontal, it's a horizontally compressed. So that means the graph should be a little bit wider with the curve, with the turn. Okay, so F4 right here, we do know that is 0. Again, just a parent graph without any reflection or any kind of vertical translation. And then half of the distance between 3 and 4. So this one is 3.5. So at 3.5 right here. So this one's supposed to be 1. But now it's being 1/2. Okay, so this one is 1/2. 1. And then let's see. Because this one you need to add 3/2 up. Okay, so keep going. So this one 1/2, 1, 1.5, and then 2, negative 3/2, -2. So just set up the scale. So 1/2, so which is right up here, and then you get a -1/2 down here. So it's cotangent. Again, this one is just the parent graph. Like that. And now with the vertical translation, so 3/2 unit up. So 3/2, so -1/2 plus 3/2, then that'd be 2. Okay, so 4/2, so it's all the way up to 2. And then down here, -1/2 plus 3/2, then that'd be, well, -1/2 plus 3/2, then that would be 2. Well, no, that would be 1, excuse me. That would be 1 right here. And then over here, so 0 plus 3/2, so 1.5. So this one would just shift the graph all the way up by 3/2 unit, 3/2 unit. So this one again, and now the parent graph. So let's just use that blue right here. Still considered dotted. It's not the final graph yet. And then finally, with the negative translation, the reflection, excuse me, negative reflection. So if this one is 2, then that means it goes all the way down to -2. Goes all the way down to -2. Up here, 1.5, then that'd be -3/2. And then over here, 1, then that'd be -1. So the final graph is going to be like a tangent curve. Just like that. Well, this one is overthrough. Should be a little bit closer here. Bound it with the asymptote. Okay, so that's it. Okay, so now we'll find out what else that we need to cover for the next part. So the next part would be secant and cosecant. So make sure that you guys just rewatch the video, especially the part that you kind of confused or there's so many stuff involved there. So try to slow things down, so pause, and then try to do some practice and focus on the detail, the information that I explained it right here, the one cycle test, because that's very important, especially once you deal with the ultimate form. So you need to start it off with the parent function first, the parent graph, and then the vertical translations or the reflections, and then the final step with the final graph. Okay? So rewatch the video and let me know any questions and comments that you have. Okay? So thank you for watching it. I'll see you guys next time. Take care.